In this section, we are going to discuss how to do various kinds of calculations using an approach called dimensional analysis. It's sometimes referred to as the factor label method. In this case, we're writing calculations such you include numbers, but also the associated units, and using conversion factors that will then cause the units to cancel, ultimately ending up with the correct unit and then the number or quantity that will be the result of the calculation. As an example of how to use dimensional analysis to solve a problem, we want to take a look at a question. Typical chemical question might be how many moles of hydrogen, in this case hydrogen gas, will be produced from 24.2 grams of sodium in the following reaction. You have a balanced chemical reaction. Ultimately, you will learn how to write these reactions, but this is a given at this point. The reaction itself is balanced so that we have ratios between the various species involved. So in this particular case, then, we would start our calculation with the given in the problem, which is the 24.22 grams of sodium. And we would first multiply by some conversion factor, which is a ratio. The conversion factor is between the moles of sodium, MOL, and the grams of sodium. And so for every 1 mole of sodium, there is 22.4 or 22.99 grams of sodium. We then, in this case, need a second conversion to go from the moles of sodium to the moles of hydrogen. And then ultimately we would arrive at our answer. The way this is all set up, if we have any unit or label that appears in both the numerator and the denominator, they will cancel. Anything that doesn't cancel will be the unit and label for the answer. So we cancel the grams of sodium and the moles of sodium, and what we're left with is the moles of hydrogen. At this point, we can do the math, multiplying everything together in the numerator and divide by everything in the denominator. You arrive at 0.526 moles of hydrogen. So conversion factors are essentially ratios that allow us to change the units within the calculation. For example, another example is that 1 kilogram, the prefix kilo, is the same as 10 to the third. That's in the equality. We can rearrange it to have one of two possible ratios. If we divide both sides by the 10 to the third grams, we would come up with a statement which mathematically is 1 kg divided by 10 to the third g's. In translating that into English, it says that there is 1 kilogram per 10 to the third grams. Alternatively, rearrange it in another direction where you take the original equality and divide both sides by the 1 kilogram, and you come up with a logical statement that is written mathematically, and it says that 10 to the third, or 1,000 grams per 1 kilogram. As another example of converting between units, we have a question that asks us to express 8 feet in terms of inches. Well, you probably know the answer already, but in this case, the given is the 8 feet, and we want to do this in terms of dimensional analysis. So we would start with the 8 feet, and we need to know some sort of conversion factor. Conversion factor is 1 foot is equal to 12 inches. We can rearrange that equality, of course, and use it as our conversion factor. So take our 8 feet, multiply by the conversion factor, which states that there are 12 inches per 1 foot. At this stage, we have a foot in both the numerator and in the denominator of the conversion factor. And so that would cancel the feet, leaving us with inches. In this case, then, I've arrived at the unit that was the goal of the question. So that means I can do my math. I know that 8 times 12 will be 96 inches, which is the typical length of a 2x4 from Lowe's. It is another example of converting between units. In this question, we have the quantity of 2.3 times 10 to the negative 8 centimeters, which is a very small distance, and we want to convert that to nanometers. In this particular case, we have to determine the conversion factor or factors that we're going to use. You may or may not know a direct conversion factor. In this particular case, it might be useful to first go from centimeters to meters, since you know what the prefix centi means, and then do an additional step. So 1 centimeter is the same as 10 to the negative 2 meters, which is equivalent to 0.01 meters. And so this is how we can represent the conversion and the equality between centimeters and meters. So the equality ultimately becomes 1 centimeter is 10 exponent negative 2 meters, in other words, 100th of a meter. And so we want to go from meters to then nanometers, so in a second step of our conversion factor. In this case, we have 1 nanometer is 10 to the negative 9. The prefix nano is 10 to the negative 9. And so we can set up our equality. We have our equality 1 nanometer is 10 to the negative 9 meters. Now we can use those two equalities and rearrange them to be our conversion factors. Okay, and we can set up the dimensional analysis to do the calculation. We start with the given in the problem. We now need a conversion factor that is going to get rid of the centimeters. So our rearranged equality states that there are 10 to the negative 2 meters for every 1 centimeter. Notice that the prefix centi in the numerator is replaced by the power of 10. And so in this case, we now have centimeter and cm in both the numerator and denominator. Those will cancel. And then the next step is converting from meters to nanometers with the second conversion factor. Cancel out all the terms that are in both the numerator and denominator, and do the mathematics, multiplying everything in the numerator and dividing by everything in the denominator. That ultimately gives you the answer of 0.23 nanometers. Right. Another example, in this case, convert the quantity of 31,820 square miles, all right, noting that miles exponent 2 is the same as a mile times a mile, and we want to convert that to square meters. And in this case, we want to deal with this in terms of 4 significant digits, which is the quantity of sig figs that are in the given. We first have to determine our conversion factors. We may or may not know a direct conversion from the miles, square miles, to the square meters, but we can go through several steps perhaps to get there. In this case, we want to go from miles to meters. We know that a given is 1 mile is equal to 1.6093 kilometers. I would not expect you to memorize that. That would be a given for you. But you should know that 1 kilometer is the same as 10 to the 3rd meters. Now we need to set up the equation so that we have any kind of intermediate units and canceling. So we start with the given, writing the unit of miles squared. We set up a conversion factor that goes from, which states that there are 1.6093 kilometers per 1 mile. We also know that there are 10 to the third meters for every 1 kilometer. Unfortunately, this is not the proper calculation because we haven't accounted for the fact that we have miles squared. So we need to deal with that issue. That means that we are going to need to square our conversion factors. When we have the square outside of the parentheses, those units will also be squared as well as the number. So if we distribute that square into the unit, we also have to distribute the square into the numbers, and then we can cancel our units. Canceling both the miles squared and the kilometers squared. Now we arrive at the unit, which is the desired answer. We can then do our math, which then multiply everything in the numerator, divide everything in the denominator, and account for the fact that we want to have 4 significant digits. And in this case, we may have to do some rounding, and we then can put it in standard form of scientific notation by moving the decimal point just to the right of the 8, which is a matter of moving the decimal point 1, 2, 3, 4 places. That means the exponent of the power of 10 has to increase, since this is a large number, so it has to increase to 10 to the 10th square meters.